We have already seen Euclid's axiom and postulates. So today we will do some of the numericals based on these axioms and postulates. We know axioms are certain general statements which are accepted without any proof, and certain general statements which are accepted without any proof and without any logical reason particular to geometry are called as postulate. The first question goes like this: which of the following statements are true and which are false? Give reason for your answer. Only one line can pass through a single point. Definitely it is false, because we know that if there is a point, you can draw infinitely many lines through this point. Suppose P is a point, I can draw many lines through that point. So infinite number of lines can be passed through a single point. So only one line can pass through a single point. That statement is false. Second one, there are infinite number of lines which pass through two distinct points. Suppose A and B are two different points. They are saying that infinite number of lines can pass through these two different points. It is wrong. Only one line can pass through these two distinct points. That is Euclid's first postulate. Next one, a terminated line can be produced indefinitely on both sides. That is Euclid's second postulate. A line, it can be extended indefinitely on both sides. So this statement is true, whereas second statement is false. Now fourth one, if two circles are equal, then their radii are equal. So that is true, because if two circles are equal, then region bounded by one circle can be superimposed on the other, and this means that the center and the circumference lie over one another, hence their radii will be also equal. So if two circles are equal, then their radii will be equal. In the figure, if AB equal to PQ, so AB is one line segment, PQ is another line segment, and PQ equal to XY, then they are saying that AB and XY are equal. So this is also true, because we know that by axiom 1, things which are equal to the same things are equal to one another. If AB is a line segment of 4 cm, PQ is a line segment of 4 cm, XY is also a line segment of 4 cm, then I can say that AB is equal to XY. By axiom 1, things which are equal to the same things are equal to one another. So this statement is true. Now the second question is, give a definition for each of the following. Are other terms that need to be defined first? What are they? How might you define them? So first one is parallel lines. Two straight lines which do not intersect each other at point anywhere are called as parallel lines. How to define parallel lines? They will not intersect each other. Two straight lines that never intersect each other, and always the distance between them will be same. So such lines are called as parallel lines. So before defining the parallel lines, we need to define point, line and straight line. So from Euclid's definition, we know that point means which has no path, line means which is a breadthless length, and a straight line is a line which lies evenly with all the points on itself. So the definition for parallel line is that two straight lines which never intersect each other. Now the second one is perpendicular line. Two straight lines are said to be perpendicular if they intersect each other at right angles. So perpendicular lines means two lines and they should be intersecting each other at right angle. So these are perpendicular lines. Now, before defining the perpendicular lines, we need to define lines as well as angles. So line, we know that it is a breadthless length, and angle means two rays with a common initial point. This is one ray and this is another ray. We can say that OA is one ray, OB is another ray. So two rays and the common initial point is O. So two rays with a common initial point is called as angle. And two straight lines are said to be perpendicular if they intersect each other at right angles. Now the next definition is line segment. A part of straight line between two points is called as line segment. Suppose this is a big line and a part of this between 2 points, let A and B are 2 points, and I can say that AB is a line segment. A part of the straight line between 2 points is called as line segment. Before defining line segment, you need to define line and point first. So line is a breadthless length and point is that which has no part. Now next is radius of the circle. How will you define radius of the circle? Length of the line segment between center point of the circle to any other point on the circle is called as radius of the circle. So radius of the circle means the distance between center and any point on the circle, that is called as radius of the circle. And radius of the circle of the same circle will be equal. All the radius, we can draw infinite radius for a circle, and all the length of the radius of the circle will be same. So to define radius of a circle, we need the point, center and circle. This has to be defined first. Point, as usual, which has no part, is called as point. Center means the point which it will be lying inside the circle, and it will be same distance from all the points lying on the circle. Suppose this is a point on the circle A, B, C, and this is the point which is lying on the center of the circle or which is lying inside the circle, and if you measure this distance, all this distance will be same. So that point is called as center. Now circle means collection of all points in all possible directions which are equal distance from a fixed point in the plane. Suppose this is a point and I am measuring 2 centimeters from this point in all the directions. I am measuring 2 centimeters, and if I join all these points, I will get a circle. So collection of all points in all possible directions which are equal distance from a fixed point in that plane is called as circle. Next is square. A quadrilateral with all sides are equal and each angle is right angle is known as square. Square means quadrilateral with all the sides and all the angles are equal, that is called as quadrilaterals. If A, B, C, D is a quadrilateral and the side AB is 4 cm, BC is also 4 cm, DC is also 4 cm, AD is 4 cm, all the sides are equal and all the angles are equal, it will be equal to 90 degree. Such a quadrilateral is called as square. So to define a square, we need to define what is side, angle and the quadrilateral. Side, it is an undefined term, and angle, we have already seen that 2 rays with a common initial point is called as angle, and quadrilateral means the figure formed by joining 4 points in the plane, that is called as quadrilateral. Any 4 points if you join in the plane, we will get the quadrilateral. So these are the definitions for parallel lines, perpendicular lines, line segment, radius of the circle and square. So the next question goes like this. If a point C lies between 2 points A and B, so A and B are 2 points, and the C lies between these 2 points such that AC is equal to BC, that means these two measure of AC and BC are same, then we need to prove that AC equal to half AB. Explain by drawing the figure. You can draw the figure like this, and C is a point lying between A and B, and they have already given that AC is equal to BC. This is given. Now we need to prove AC equal to half AB. So both sides I am going to add AC. So AC plus AC equal to BC plus AC. Both sides I have added AC. So we know the axiom, if equals are added to equals, the whole will be equal, there will not be any change. So AC plus AC is 2AC, and we know that BC plus AC is the full length AB. Now if I take the 2 to the other side, it is half AB. So this is what we need to prove. AC is equal to half AB. Now the next question is, if C is the midpoint of line segment AB, so this is the line segment AB and C is the midpoint of line segment AB, prove that every line segment has only one and one midpoint. So every line segment will be having only one and one midpoint that we need to prove. So let us assume that there are 2 different midpoints, say C and D for this line segment. One more midpoint is there, let it be D. So I am assuming that there are 2 different midpoints for this line segment AB. if C is the midpoint, just now we have proved that if C is the midpoint, I can write AC will be equal to half AB. Just now we have proved in the previous sum. Or I can write 2AC is equal to AB. Same way, if D is the midpoint of the line segment, then I can write AD equal to half AB, or I can write 2AD equal to AB. Now right side will be is equal, therefore the left side will be also equal. 2AC equal to 2AD, and we know that from the axiom things which are double of same things are equal to one another. So AC equal to AD, this 2 and 2 I can cancel, so AC is equal to AD. So what does this mean? AC is equal to AD. So this is possible only when both the points C as well as D coincide. What does that mean? This is possible only when both the points C and D coincide. That means C and D are not two different points. So our assumption is wrong. Every line segment, what is our assumption? We have assumed that let the line segment will be having two midpoints. So our assumption is wrong. So we can say that every line segment has one and only one midpoint. So what we have done is we have assumed that let the line segment is having two midpoint. So if AC is the midpoint, then I can write this relation AC equal to half AB. From this I can write 2AC equal to AB and AD equal to half AB, since D is also the midpoint of the line segment. From this I can write this relation, and things which are double of same things are equal to one another. So 2AC equal to 2AD or AC equal to AD. That means C and D should coincide, and therefore our assumption is wrong. Every line segment has got only one and one midpoint. Now the next question is, in the figure, if AC equal to BD, then prove that AB equal to CD. So they have given AC equal to BD. Now from this figure, I can write AC as AB plus BC. I can write AC as AB plus BC, the full length AC. Same way, I can write BD as BC plus CD. BD means BC, this length plus this length will give you the full length BD. Now let this be equation number 1. Now just they have given that AC equal to BD, so I am going to replace this BD by AC. So AC equal to, remaining everything I am going to write as same. This is equation number 2. Let this be equation number 3. So we got AC equal to BC plus CD. Now I am going to add first equation and third equation, or we can say from 1 and 3. From 1 and 3, just pick out the first equation and the third equation. You can see that left side is equal, therefore the right side will be also equal. So I can write AB plus BC equal to BC plus CD. So first equation is AC equal to AB plus BC, and the third equation is AC equal to BC plus CD. So left side is equal, therefore right side will be also equal. Now we know the axiom, if equals are subtracted from equals, the remaining will be also equal. So we got AB equal to CD. So this is what we need to prove, AB equal to CD. If in the figure, if AC equal to BD, then prove that AB equal to CD. So finally we have proved that using the axiom, if equals are subtracted from equals, remainders are also equal. So thank you for watching the video.